In this lesson we're going to learn some more rationalizing denominators, but this time we've got cube and fourth roots. So same situation as before, we've got square root of a fraction, or cube root this time of a fraction, so you need to rewrite it to be the cube root, and the 3 needs to stay, not square root anymore. Cube root of 27 over the cube root of 16. So I broke it up, it's root of the top, root of the bottom. And then you want to simplify if possible. There is actually a cube root of 27. So you should do the hockey stick of 27. You're looking for groups of 3. If I divided this by 3, this gives me 9. Divide by 3 again, and I get a 3. So I have one group of 3, which means that equals 3. And then you do the same thing with the 16. Try to reduce that. So 16, I hockey stick that, and I should end up with 2 and 8, 2 and 4, 2 and 2. Now there's one group of 2's and the 1, 2 left over. That means I get to pull a 1, 2 out, and then there's still a cube root of 2 left over. So now this is where I'm stuck and need to rationalize, because I've got everything is fine except for one root there, and it's actually a cube root. Well, I've got lots of students that just try to multiply top and bottom by cube root of 2 and think that they're done. Now, it seems all fine, but a cube root of 2, in order for that to cancel, really what you need is a 2 to the third power. This is what we're looking for. So far, if I multiply it by 2 and 2, I've got 2 squared. In other words, I need one more of these cube roots of 2. So that will give me the 2 cubed, so that way the cube and the root can cancel to be left with the number on the inside. So when you've got a cube root or a fourth root, or however many root, you need to multiply it as many times as the root symbol says. So this one has a 3, so we need 1, 2, 3 of them in order for it to actually cancel and give us just a 2. So we've got the original 2 that was there before, and now we've got our new 2 that comes from multiplying 3 roots of 2. That gives us this last 2. So however many times the root is, that's how many times you got to do it. And then on top, you end up with 3 cube root of 2 squared. And that didn't show up very clearly, but let me rewrite it. So it's 3 cube root of 2 squared. Okay? Now, that's not the final answer, because I do actually need to take the bottom and multiply 2 times 2. Okay? So I'll just erase that and put the 2 there. Or the 4, sorry. So this is your final answer. Okay? So again, don't get lost because I erased it. You had 2 times 2, and then I just put the 4 there. Okay? So let's take a look at this next problem. It's a little bit simpler. I don't have as much simplifying to start off with, but I need to just notice right away, this is a cube root of 2, so to get rid of it, I need 3 total, so cube root of 2, and then times one more, a cube root of 2. Then on top, same thing, cube root of 2 times cube root of 2. Hopefully, you might get good at it. Notice, really, I'm multiplying by the cube root of 2 squared. Hopefully that doesn't throw you for a loop, but really, let me explain that. You're multiplying by it twice, so really that's just the cube root of 2 squared. So if you want to write it out just like I did here, you'd get the same thing. The top turns into 3 cube root of 2 squared. On the bottom, we end up with the 3 of these turn into just 1, 2, and then there was still that original 2 that was in front, so we'll put that one there. So the final answer here would be 3 cube root of 2 squared. It's actually the same answer as the last problem, over 4. Okay. So that's just kind of the second part worked out again. The first one had a little bit more simplifying to do originally. So this time we're going to throw a fourth root in there. And notice again it's square root of a whole fraction, so we want to break it up. Square root at top, the fourth root this time of the 5x, and the fourth root of the z. Now, I can't simplify anything because I don't have any powers here in the 5, the x, and the z. So I need to multiply. I need another 3 z's. So I can either write it out like this, or I can save myself space and realize I'm multiplying by the 4th root of z to the 3rd. Because really I just have 1, 2, 3 z's, and so it's really just 4th root of z to the 3rd power. So whichever way makes more sense to you, write it that way. So that's what you multiply top and bottom by. These are in fact the same thing, the top and the bottom. Okay, so I just multiply, and that's going to give me 4th root of 5x z to the 3rd. And on the bottom, I'm left with just 1 z, because this turns into the 4th root of z to the 4th power, and that is z. Okay? So this is your final answer there. So hopefully these aren't more complicated for you, it's just you need to do it more times. So now we're going to work on rationalizing with a binomial denominator. And the key here is I've got two things with a plus sign. Many of my students think, well, let's just multiply top and bottom by square root of 2. And they'll do that on a test. And if you did that, actually, all you would end up with is 3 square root of 2, but the bottom you would actually need to distribute that, and you'd end up with a square root of 2 again. Square root of 2 plus 4, or a square root of 4, which is 2. So this doesn't help you if you just multiply by the square root of 2. The key is I need to multiply by what we call as the conjugate. And we talked about these earlier, but what that means is we need the same binomial with a minus sign, or if it's a minus sign, with a plus sign, just the opposite of what the middle sign is. So do the same thing, same numbers, opposite middle number. Okay? And the nice thing about conjugates is you don't have to do the whole FOIL process. You don't have to do the whole thing. You just do the F and L with no OI. Okay, so in other words, just the first, just the 1 times the 1, and that gives me 1. Just the square root of 2 times the negative square root of 2, which gives me negative 2. Now there's no denominator, or no root on my denominator. And on the top, you just distribute straightforward. 3 times 1 is 3. 3 times negative square root of 2 is negative 3 square root 2. And now we just simplify. I need to turn this into 3 minus 3 square root of 2 over negative 1. Okay? Now, if it were possible to simplify so this is my final answer, but let's just say, for the sake of you having a problem like this in your homework, you had 3 minus 3 square root of 2, and let's just say it just so happened to be actually a 6 or a 3 or something like that on the bottom. You have to do what I call a Dorito problem, and you need to, it's called a Dorito because it makes a triangle, and I use orange, so this is a nacho cheese Dorito problem, and I want to divide all of them by whatever number they have in common. Okay, and the root would not be included here, so you don't include the root in your Dorito problem. So you just take a look at the 3, and the 6, and they would all have a 3 in common, so I would divide them all by 3. So I would turn into 1 minus 1 root 2 over the 6 would turn into a 2. Okay, I divided them all by 3. So again, this is a side example. Okay, it has nothing to do with this problem because that one's done, but this is possible that you might see a Dorito problem in your homework. Okay, they're also called a triangle problem, but I just like to spice it up because Doritos are good. So let's take a look at this next one. In this one, I want to multiply the top and the bottom by 4 plus the root 3. Okay, so still conjugates, 4 plus the root 3. Same numbers, opposite sign in the middle. So now I multiply the 4 times the 4, and that's going to give me 16. The second one gives me negative 3 and positive 3. That's going to give me negative 9, negative square root of 9, which is 3. And then on the top, I distribute. The 5 times the 4 gives me 20. And the 5 times the 3 gives me, the root 3 gives me positive 5 root 3. Now you go ahead and simplify. The top doesn't do anything, it's just 20 plus 5 root 3. At the bottom, we need to subtract, and I get my 13. Now again, this one is not a Dorito problem. It doesn't simplify at all, but you might see some of that in your homework.